Hello everyone, welcome to my session today. Today I want to propose about the service function training, in OpenStack. First I want to introduce a little bit about myself. My name is Dong Feng and I'm a senior system engineer from Huawei. I'm currently located in Huawei Nanjing Research Institute. My slides will generally cover the certain aspects. First, I would like to give you an interview of what is service function training. As all of you might have known that service function training provides the ability to define an ordered list of network services. All service functions like firewalls, load balancers, DPI, tick from a set of packets. Services across the network switch together to create a service chain. You can see from the picture that a certain flow can be steered to a different ordered list of service functions. Why is service function training? In the big background is that in a network function virtualization, a lot of network functions previously it was implemented using hardware is now virtualized into software, which resides on the commercial off-the-shelf software servers. Before there were a lot of limitations using the hardware network functions. The limitations are fragmented non-commodity hardware and physical install per appliance per site is very low efficient, and if you use hardware, it's low asset utilization and limits modularity and vendor choice. In the future, it goes into the virtualized software, which runs on certain standard servers. We can gain the benefits like we can gain flexibility and extensibility and high asset utilization and continuously developed and upgraded. We can gain software benefits which can enable the reduce capex and reduce TCO, and we can achieve modularity, and it will be more in an agile way. This slide I want to go through the problems of current OpenStack for service chain and the future improvement. In a service chain architecture in NFV environment, there might be certain building blocks. First, we would have the E2E orchestrator. In the E2E orchestrator, we will have the service chain orchestrator and NFV orchestrator. Below the NFV orchestrator, we will have the VNF manager. VNF stands for the virtual network functions. The VNF manager will manage the life cycle of different VNF, also known as virtualized enablers. In the Cloud OS, which is generally controlled by OpenStack, OpenStack being the choice for the virtualized infrastructure manager. We will have different virtual switches. Virtual switches will connect to different value-added services. And in the service orchestration orchestrator, we will have the chain selection policy server, which will define and enable the service chain according to the user inputted flows. Here I will go through the typical flow of how to automatically service provisioning in every environment. First, user need to create a logical service chain in the service chain orchestrator. Then, user will request a new value-added service instance. Third, we'll request VRM, typically OpenStack, to allocate a new VM for the instance. And the fourth step would be create a new virtual machine and load the image which is intended to run on the instance. The fifth step would be synchronize the new value-added service, say video object instance profile and logically service chain definition. Okay, like the characteristics, status, capacity, address, and attached virtual service switch to SC controller. SC stands for service chain. Okay, and the sixth step would be according the logical service chain definition and the new adding VM instance. The service chain orchestrator would generate service chain flow tables for the new adding instance and send it to the virtual service switch. The virtual service switch steers traffic to the new instance according to the policy. Okay, the current problems in OpenStack service chain is there is no open interface to integrate OpenStack with different vendors' service function instance, both virtual and physical. And service function instance created by many existing service devices need to be included to provide service chain ecosystem and OpenStack umbrella. And currently, OpenStack has no well-defined open interface to allow registration of third-party service chain orchestrator, flavor, and capacity information. And vendors will have to develop their own proprietary interfaces. And currently, OpenStack has no normalized interface for different vendors' service chain drivers. And service chain brings low capex and opex by auto-provisioning and steering different tenant flows through different sequence of service functions. And vendors will have to develop a proprietary driver interfaces to OpenStack to get service chain functionality. Okay, in the OpenStack service components and instance, we propose like this. Okay, first we would have the OpenStack service chain orchestrator, which is defined in OpenStack, and it will offer the typical and the common northbound RESTful APIs for doing service chain. Okay, inside the service chain plugin, which would be a service plugin, we would have a service chain plugin, which would act as a service chain, also act as a service chain manager. And we would have a common southbound interface between the service chain plugin and vendor-specific service chain drivers. It would be the service chain driver interface. And moreover, we would have the service function instance manager, which could be a third party. And there is a standard interface between the OpenStack infrastructure and the service function instance manager, which we define as a SFI registration interface. So through this interface, the third-party instance manager can register their service function information into OpenStack, so that future OpenStack can use this information to dynamically orchestrate the flow. Okay, typically we would have a lot of vendor driver. Say any vendor service path construction control. It could be easily incorporated with current SDN solutions. Okay, or Neutron itself will act as a service chain controller. Okay, if Neutron itself acts as a service chain controller, we would have using OVS, Open vSwitch, as the service function forward, and on top of Open vSwitch, the OpenStack would calculate and install the requested flow table on the OVS, and OVS will act as a service chain classifier, which will classify different flow according to user request and steer the flow into different value-added service using openflow tables. Okay, and we support multiple instances of OVS, and we support tunneling between different instances of OVS. Okay. Okay, it would be a typical use case. Okay, in a cloud environment, maybe a CSP, which stands for Content Service Provider, provide a video delivery server, and some user would have to access the server, okay? But the traffic would be firstly examined by the firewall. Say that maybe some user want to, some attacker want to attack using DDoS to block the service. So if using service chain, okay, if the service is examined by firewall, then the attack would be mitigated using the firewall instances, okay. Here are around the proposals in this area. We have a lot of service chain and proposal in OpenStack. Okay, in the future we will focus on the to incorporate all these proposals together and to deliver service chain maybe in the coming Liberty release. Okay, if you are interested, you can feel free to contact us. Okay. Okay, that's about another summary. Okay, and the key takeaways we can create. Let me summarize this presentation. Okay, we can create and change service function as per the needed, and we can use Neutron APIs to provision service function chaining, and we can orchestrate, trade and control can be carried out using the central client. Okay, that's all for today. Thank you all for coming to the session. Okay, thank you very much.